continue on reviewing the functions. Next thing, let's talk about a vertical line test, right? Vertical line test is used to determine whether or not a relationship is a function, used to determine function using the graph of the function. So basically, you draw the graph of the function, and we draw the vertical line. So if the vertical line only intercept the graph of the function once, like the example B and C, right? You draw the vertical line, there's only one intercept. Draw the vertical line, one intercept. That means it's a function. Like C, same thing. Draw the vertical line, one intercept. Draw vertical line here, one intercept, and then vertical line here, zero, no intercept. So B and C are both a function of x, but A is not, right? If you draw the vertical line here, we're gonna have two intercepts. That means this indicates one x value produces two y values, right? One x value creates two y values. Not a function, right? That's why this A is not a function. Now let's take a look at some of the basic functions and their graph. First one is called identity function, f of x equal to x. So basically it's y equal to x. So it's a straight line passing through the origin with a slope 1. Right? So this is the identity function. The second one is a square function. We also call this quadratic function. And again, it's f of x equal x squared, and the symmetry with respect to y-axis, right? It's parabola opens upward. And the third one is a cubic function, a cubic function, f of x equal to x cubed. And this one is a symmetry with respect to the origin. And then the fourth one is a square root function. They are functions, right? If you draw a vertical line, they all only have one intercept. Right? Vertical line, one intercept. Same thing for the square root function. If you draw the vertical line, there's only one intercept. That indicates one x value only produces one and only one y values. Same thing, absolute value function. It's passing through the origin, and it's symmetrical with the y-axis. On the left-hand side, it's f of x equal to x. On the right, on the left-hand side, is f of x equal to negative x. And also the rational function 1 of x. So both x, y axes are the asymptotes of this rational function. But if you draw the vertical line, right, only have one intercept here. Same thing here, vertical line test, only one intercept. And also f of x equals sine x, and f of x equals cosine x. Cosine x, this is one's typical cycle, right? And then cosine x is one typical cycle. These periodical functions. So those are the 8 important basic functions, and you need to know how to graph them very quickly. And let's take a look at transformation of the functions. Right, so basically it's shifting up, down, left, right, and also refractions, horizontal shift, vertical horizontal shift. Second one is vertical shift. And the third one is refraction. So let's take a look at some of the examples here. So start with the function y equal x squared, which is this one of the 8 basic functions. So let's start with this one right here. then the first function x squared plus 2. So basically vertical shift 2 units upward, right? Go up 2 units. Shift up 2 units. So basically 1, 2, right? So all these points shift up 2 units. So this one go up 2 units, goes here. Every single point go up 2 units. So end up with this. Y equal x squared plus 2. Now going from this function to this function, y equal x plus 2 squared. So we move to the left 2 units, right? Shift to the left 2 units. So you get x plus 2 squared. And shift left. Shift to the left 2 units. And the third one is a reflection about the x-axis. So basically y value becomes opposite, right? Originally it was x squared, now it's minus x squared. So this is reflection about the x-axis. Because y becomes the opposite. So all this y value becomes exactly opposite. Y value becomes opposite. And then the third one, it's a series of the transformation. You start with the reflection about the, so going from this function to this function, reflection about the x-axis first, right? So you get this. So going from this to this, it becomes y equal to minus x squared. Now we do shift to the left 3 units, right? So it goes here. So now this one becomes y equal to minus x plus 3 squared. After that, we shift up 1 unit, go up 1 unit, so adding 1 in the back. That's how we get this. Okay. So 3 different transformations, right? First one, reflection about x-axis. Second step, shift, horizontal shift 3 units to the left, shift to the left 3 units. The third step, shift upward 1 unit. So we're going from y equal to x squared to y equal to 1 minus x plus 3 squared. Yeah, so this is basically just a summary of what we did, right? From the previous slide. So this is basic transformations. We start with the original function y equal to f of x. Then horizontal shift c units to the right. You subtract c from x. Horizontal shift c units to the left. You add c to the x. Vertical shift c units downward. You subtract c from the function f of x. And then vertical shift c units upward. You add c to the function f of x. Reflection about the x-axis, the y value becomes opposite, right? So f of x becomes minus f of x. Reflection about the y-axis, then the x value becomes the opposite. X becomes minus x. And reflection about the origin, x becomes negative x. And then y value becomes minus, right? Becomes the opposite. So that's basically all the basic transformations you need. And let's also take a look at the classification and combination of functions, right? Start with the classification of the functions. We have 3 different major categories. First one is algebraic functions, like polynomials, radical functions, and rational functions. Those 3 are 3 major branches of algebraic functions. And we also have trigonometric functions like sine, cosine, tangent, cotangent, secant, cosecant, right? And the third type is exponential and logarithmic functions. Okay. So those are all called elementary functions. Let's start with the polynomial functions. So we get f of x equal an subscript n x to the n power. And this is what they call this an times x to the n. It's called a leading term. An is called leading coefficient. And then x to the n is called the leading power. And this is very important, right? It determines the degree of the polynomial function. And this one is called the nth degree, right? Nth degree. Polynomial function. And then next term is an minus 1, xn minus 1. And then the last couple terms, a0 is the constant. Right? A0 is what we call constant. And here n is a non-negative integers. And also we can look into some lower degree polynomial functions like 0 degree, right? We get this called constant function. F of x equal to a. First degree ax plus b is called linear function. Second degree ax squared plus bx plus c is called quadratic function. And the third degree ax cubed plus bx squared plus cx adding b is called cubic functions. Okay. And we can write more, right? Like fourth degree f of x equal to ax to the fourth plus bx cubed plus cx squared plus dx adding e, right? That is fourth degree. So the leading power determines the degree of the polynomial function. We also have a rational function. And the rational function basically is a polynomial function over another polynomial function. So it's actually a polynomial function over another polynomial function. And so we here both px and qx are polynomial functions. And also have both polynomial function and rational function are examples of algebraic functions. And an algebraic function could be expressed as a finite number of sums at difference, multiples, quotients, and radicals involving x to the n, right? Power function. X to the n is called power function. So for example, f of x equal to square root of x plus 1 is algebraic. It's called a radical functions. And then the functions that are not algebraic, it's called transcendental. Transcendental functions. For example, trigonometry functions are transcendental functions. Okay, so two functions could be combined in various ways to create new function. For example, let's say with f of x equals 2x plus minus 3, gx is x squared plus 1. So if you add in them f plus g, meaning you add in f of x and g of x, so you get a new function, right? So and we subtract then f minus g. So basically it's f of x minus g of x is called a difference of two functions. F times g and f of x times g of x is a product of two functions. And f of x over g of x, f slash g is f of x over g of x, and this is called a quotient of two functions. And you can combine two functions in another way called a composition. So also this is composition function, composite functions, right? We're going to take a look at the composite function, f composite of g, g composite of f. So first one, let's look at the definition of composite functions. Let f and g be functions. The function given by f composite of g is f of g of x. It's called composite of f with g. So the domain of f composite of g is the set of all x values in the domain of g, such that g of x is also in the domain of f of x. That means the domain of f composite of g must satisfy both function f of x and g of x. Okay. And also this diagram shows you the relationship, right? The domain. Yeah, so composite f composite of g, the domain of that will be both satisfying both domain of f of x and g of x. And the composite of f with g may not be the same as the composite of g of f, right? So meaning f composite of g is not equal to g composite of f. Same thing as saying f of g of x is not the same as g of x. Yeah, so let's take a look at how we create a composite function with the two given functions, right? Let's say f of x equal to 2x minus 3, g of x equal to cosine x. I'm going to find each composite function here. First one is f composite of g. That means we're talking about f of g of x. And this function here, replacing g of x with the cosine x, we should get f of cosine x. Now go back to the f of x, replacing x there with the cosine x. We get 2 times cosine x minus 3. So this is f composite of g. Secondly, g composite of f is same thing as saying g of f of x. Here we get g of replacing f of x with 2x minus 3. So we get g 2x minus 3. And going back to the g of x here, replacing x with 2x minus 3. So cosine x becomes cosine 2x minus 3. As you can see, they are not the same, right? So again, it proves f composite of g is not the same as g composite of f most of the time. So that's basically the composite functions. That's how you find the composite functions step by step. Now let's take a look at classification combination functions. Here we also have even function. The function is even if its graph is symmetric with respect to y-axis, and then the function is r if it's symmetrical with respect to the origin. So even function is defined as f negative x equal to f of x. Here, x becomes the opposite, but the y value are the same, right? So in that case, if you look at it, x is here now becomes negative x. So in that case, it's so this point here, x value becomes negative x. So that's why it's symmetrical with respect to y-axis. And our function f negative x equal to minus f. That means here x value are the opposite and the y value are the opposite. So let's say the point here is xy now becomes negative x, negative y. That's symmetrical with respect to the origin. Now let's determine whether below function is even, odd, or neither, right? So for A, because all the r powers, right? So it will be up function, but we can double check. We find out what is f negative x. F negative x equal to negative x cubed minus negative x. I end up with minus x cubed plus x, right? And if you factor out negative sign, we get x cubed minus x. And this is exactly the f of x, right? So it's minus f of x. So that means this is definitely an R function. And then B, because cosine is an even function, so g of negative x, let's find what is g of negative x, 1 plus cosine of negative x. Cosine of negative x is the same thing as cosine x. So this is the same as the original function g of x. So that means it's even function. And if you look at the now let's look at the 0 of g of x, right? 1 plus cosine. So g of x is 1 plus cosine x. In order to find the 0, we set g of x equal to 0. So 1 plus cosine x equals 0, so cosine x equals -1. And if for cosine x to be -1, it will be pi, right? Cosine pi equals -1, and then we can add subtract the cycle, right? 2 pi, 2n pi. So it will be, this will be x equal to pi plus 2n pi. And here n is the integer. Okay. And if you factor out the pi, then we know x equals 2n plus 1 pi. As you can see, this 1 plus cosine x, right? So here this is 0, and this is 0, 3 pi, 0, and then 5 pi, 7 pi, and negative pi, all of this. So that's basically everything on this section.